Hello?
Oh, yes.
Oh, yeah.
Oh, let's see. Is that better? Or you might be better?
Yeah, better?
Okay. Hi, I'm Kim Mohler, and just to give you a background, so I'm a petroleum engineer from the University of Alberta. I've got close to 42 years now, approaching 42 years of experience in the oil and gas industry and energy industry. So I've worked for a bunch of big companies. I know a fellow here was talking about a bunch of companies, but I was with Dome. I used to work at Dome Petroleum. That sort of dates you. And then Amoco and CNRL. I've had history with quite a few different companies, and PetroChina. And been with GLJ, as Willie mentioned, about 6 or 7 years now. So I'm going to start off by giving a land acknowledgement. And so GLJ acknowledges the traditional territories of the peoples of Treaty 7 region and the Métis Nation of Alberta, Districts 4 and 5, and would like to recognize that our work supports energy operations in and around Indigenous lands in Alberta and across Canada and internationally. So today I'm just going to do an intro to GLJ for those of you who might not know our company, and then talk a bit about critical minerals, and then I'm going to focus in on lithium brines, and sort of give a background on some of the projects that GLJ has been working, and then do a summary and questions at the end if that's okay. I'd like to hold questions for the end. Yeah, oh. It might jump. Let's see. Oh, no, it did. Sorry, just getting used to this computer. Oh, there we go. Okay. So yeah, we are headquartered in Calgary, and we've been in business for over 50 years, and we work across about 80 countries around the world. We have over 100 people, engineers, geoscientists, and business professionals and sustainability professionals. And we have about 200 clients that come back to us annually. What do we do? So we're an independent evaluator. We do certifications, audits, and so mostly on the reserve side. So the core part of our business is still oil and gas. That is where a big part of our business is. But the last 10 years, we've really been expanding and moved our business into international and also to some other areas. So here we just talk about the reserves and resources, reservoir studies that we do, modeling and simulation, litigation mediation, and A&D and sustainability and ESG. So on the business diversification side, yeah, we're moved a lot into the international. We're in carbon capture and utilization sequestration, so CCS, CCUS. We have have done quite a few studies in the last about 6 or 7 years on using that. Emerging energy and geothermal and hydrogen. The team I'm with, we work geothermal and a lot of lithium brines. I myself also have been working in the SAGD and thermal industry for thermal recovery for 20 plus years. So that's another part of how I actually got into the geothermal world. And then critical minerals, I'll talk about the lithium brines. So critical mineral strategy, many of you have probably seen, 2022, the Canadian government put out the critical mineral strategy. And so they provided sort of all the different critical minerals that we're looking at in Canada. What I've bulleted, sort of put into the little yellow balloons, is those that GLJ has been working with. And when we look across Canada to see where the critical minerals are, we have kind of all over the place. When we look in on Alberta, we actually have lithium brines, and so I'll be talking more about that, and specifically in about the Alberta, but also internationally. So what's driving the demand for critical minerals? Obviously the energy transition, climate change, and lowering greenhouse gas emissions, the growth in the electric vehicles, EVs, production, and EV batteries. And then countries are wanting to be self-sufficient. They want to have their own supply, and manufacturing. And the next part, supply chains that are carbon competitive, environmentally sustainable, and respectful of human rights. This actually comes out of the 2022 Critical Mineral Strategy for Canada. And there are, policies that are starting to be developed in Canada and across the world that are supporting the exploration and development of critical minerals. So there's more grants, tax incentives, and a lot more move on the infrastructure side to provide power, roads, pipelines, and funding, obviously, to get investors inside. The chart on the right shows growth between 2022 and 24 of several of the different critical minerals. And I'm going to talk more about lithium, but we've seen a lot of growth in that market, and that is directly related to EV batteries. So I'm going to talk about lithium brines. So for the global lithium supply, the supply at present is from hard rock mining and from brine salars or evaporation ponds. So the diagram on the top is a mine in Australia, a lithium mine in Australia, a hard rock mine. And then in the bottom is one of the large salar projects in Chile. So Chile and Australia are two of the top producers of lithium in the world right now. China is third. And they really do, these types of developments have very large footprint and environmental impact. So the direct lithium extraction technologies, DLE, are starting to expand the opportunity to produce from salars a lot quicker. Salars can take 10 years plus for production, and so moving it to days, and deep subsurface brines. And I'm going to talk more about deep subsurface brines. And the adsorption-based DLE is one of the most popular. There's quite a few different technologies that are bucketed under the DLE, but that represents about 10% of the global production today is from DLE. So lithium from deep subsurface brines, when we look at the diagram on the right, this is actually from Standard Lithium, and Standard Lithium is a Vancouver-based company that operates a project, or is building a project in Arkansas. And this is from their Smackover project in Arkansas. And what we see is that their play is over 3,000 meters deep, and they would produce from the lithium-rich brine is produced to surface and goes through the facilities, and then the lithium-depleted brine is re-injected for pressure maintenance and reservoir management. So some of the advantages for deep subsurface brines are that we have the geologic and geophysical data available. So having existing oil and gas plays has really opened up a lot of use. The Smackover is a very well-developed oil and gas play, much like some of the plays in Alberta. And so that the technologies too that go behind how we would explore, run seismic, and do well tests all come from oil and gas. It's pretty well transferred from there. The deep well drilling, a lot of these projects, though they've got here vertical wells, they actually are putting in very long horizontals, and they're using verticals and horizontals. But there is directional and horizontal drilling technology basically coming from oil and gas. A lot of it is coming from oil and gas. So this type of development is much greener than the current hard rock mining and salars. You use multi-well pads, really consolidating a lot of the development, and then expanding your targets in the subsurface. You can incorporate geothermal power generation in plays where the temperatures are sufficient for that, and I'll talk more about that, give an example of a project. And then the DLE processes really are proven. I know when I first started working in this, people were saying, oh, the DLE is not proven, and it's like, well, the processes themselves that are being used have been used for decades for other types of mineral extraction. So they're actually quite proven. Now it's just testing them out with specific brines and trying to make them more efficient. So the operating costs are lower for lithium using DLE with these deep subsurface brines. It's cheaper than doing the hard rock or salar projects. So in Canada, where do we have lithium? So in Alberta and Saskatchewan, in Alberta we have definitely lithium resources. We have no commercial projects, no commercial scale today. Some of the hard rock mines in eastern Canada are coming back on production, but we do have deep subsurface brines. We have several projects that are in a pilot or demonstration stage. So if you've heard of E3 Lithium or Lithium Bank, Prairie Lithium in Saskatchewan. So Prairie Lithium and E3 both have demonstration scale facilities going on, and they're building up to commercial. So we're de-risking, a lot of these projects are de-risked through the existing oil and gas. The formation in Alberta is Leduc. The Leduc has got all the parameters, all the reservoir quality that you want for the lithium brines. So the lithium concentrations in Canada, though, aren't as favorable as some parts of the world, but they have seen up to 140 parts per million. So we can talk a bit about the synergy of geothermal with lithium. So the diagram on the right basically shows a simplified plant. So we kind of saw that with the one from Standard Lithium. This just shows it a bit closer. That in the red, you've got your hot production coming up with lithium enrichment. It basically uses a heat exchanger to take the heat off, run a turbine, and produce power. You can also take heat off of that for district heating. And then the lithium heated brine as well goes into the direct lithium extraction process. Remove the lithium, it goes for refining and processing, and then you re-inject the lithium depleted and cooled brine back to the reservoir. So it can be a good source for the lithium extraction, but you can also have other critical mineral extraction. If it's in sufficient quantities, there are a few projects out there that are looking at dual types of products coming out of the brine. And then it can be integrated with existing geothermal. So where there's already geothermal, and not so much in Canada, but in other parts of the world, and the example I'm going to show is one of them, you actually have the data available and you can integrate it. So it is green power, it's harnessed from the brine, and it basically uses a binary an ORC plant to produce it, and then it reduces the operating costs of the direct lithium extraction. So the processing and refining and the DLE both are energy intensive. So at least if you can get geothermal power, you can offset some of your power requirements. Plus you have a high parasitic load for the pumps. To produce this fluid from 3,000 meters below the ground is very intensive. So when we leverage some of our expertise, the subsurface expertise, these are reservoirs that are basically the same as like oil and gas. We're all used to seeing it. And so the technical evaluations are very similar. We just focus a bit more and add into there the geochemical side, and in the case of geothermal on the temperature side. The static and dynamic modeling methodology and even the software can be the same, so as oil and gas developments. The picture on the right is a subsurface model of the Vulcan Lionheart Phase 1 project. And so we can see they start out with vertical wells and then put directionals in. It's a faulted system. And so we see the faults in the yellow colors, and basically a nest of different multi-well pads that they're putting in. So Vulcan Energy, I'm going to talk about them now the next couple of slides. It's an Australian company that's traded on the Australian Stock Exchange and the Frankfurt Stock Exchange. Their project is located in the Upper Rhine Valley of Germany. And they basically own and operate existing geothermal plants at Insheim and Landau in Germany. There's been quite a few companies supporting Vulcan. So GLJ has been one of them, but we've seen Apex Geoscience and Hatch Engineering have supported Vulcan in its journey as well. So we do see quite a bit of Canadian companies actually we ran into quite a few Canadian companies in Germany supporting projects there. So we've been supporting them since 2020, and I signed off as a competent person under Jork on the ore reserve side. So location of this project is in the beautiful Rhine Valley. So if anybody's been on a Viking, one of the river cruises, you go down the Rhine River and the vineyards and everything. It's quite populated. There's little towns everywhere. In the bottom of the lower diagram is the Insheim geothermal plant. So that's an existing plant. There's actually a community right beside there, and they're going to be providing heat to that community starting this year. They have quite a few licenses, all in the Upper Rhine Valley, that go all the way into France. So it's not just in Germany, but all the way into France. And right now they're focused on their Phase 1 in Lionheart area, which is near Landau, Germany. On the subsurface side, the target formation is the Buchenstein. It's between 3,000 and 4,000 meters deep, and it's 165 degrees C. So that's why the geothermal production, and it has a pretty favorable lithium concentration of 181 parts per million. So they did start drilling last year, and so they actually just TV'd their second well just a couple days ago. And so this is their drilling rig that they have on their Scheilberg first drill location. They've got four drill locations set up out of here. And again, this diagram in the bottom basically shows the same process that I was showing before. It's just Vulcan's version of their whole production, from drilling the wells through to the hot to the cold side and producing lithium chloride. Now their integrated process looks a lot like oil and gas. So when we look at it, it's upstream, midstream, and downstream. And so you move through, they start from the reservoir on the left side through to the wells, produces the geothermal heat and power, and then they have the direct lithium extraction plant, and from that they're going to produce lithium chloride. They're trucking the lithium chloride to a centralized lithium plant that's for refining and processing, and it's located near Frankfurt, Germany. So the Landau facility is less than an hour drive. It's like about a 45-minute drive from the Frankfurt location. So they end up producing a lithium hydroxide monohydrate, an LHM product that's a battery, very high quality battery grade. And they've got offtake agreements already set up with Stellantis, Volkswagen, Renault. They've got quite a few. And one of the advantages they have is that they're located in the Upper Rhine Valley and in Germany near Frankfurt, where so much auto manufacturing is being done. Plus the batteries are even being manufactured there. So it's a very sweet spot. They've got the temperature, they've got the lithium, and they have the offtakes. The project's starting up in 2028, by the way, commercial scale. So in summary, I've got a couple slides on this, basically to sort of give some highlights, is that, you know, our Canadian energy professionals really are well positioned. We have the expertise, we have the skills, capabilities to support the critical minerals sector. There are more incentives coming, and, you know, in Canada, there's some, but a lot of the countries are really putting more into this to try and become more self-sufficient. And the co-production of other critical minerals could be possible if they're economic to add on. And then you can leverage the existing subsurface data, as I mentioned before, and sometimes existing infrastructure. The case of the Lithium Bank project in near Fox Creek, Alberta here, they're actually going to be using some of the existing oil and gas pipelines, taking over some of those and repurposing them. We're also utilizing some of the regulatory experience we have from the oil and gas side or mining side and taking that into the lithium brines. So we look at the little diagram on the top, just sort of shows as technology is advancing, we do find the regulatory side sometimes has to spend a little time to catch up to see how's this going to apply. For lithium brines in Canada, they're regulated under NI 43-101 under the mining regulations, which doesn't necessarily fit with a brine type development, these deep subsurface brines. I know E3 Lithium has spent a bit of time advocating, trying to look at saying NI 51-101 would be a better place for it. We see this with other companies around the world. In Australia, it's also the mining regulation. But it's something that it's between. It definitely fits in between. We'll have to see how things catch up, but it is that whole part of seeing how these projects get to commercial and how the regulatory side or disclosure requirements will maybe catch up to it. Some of the challenges we see is that the cost of putting in wells for exploration is very high. In Alberta, where we actually have some potential for geothermal even, and potentially good lithium concentrations in the Leduc along the foothills, can cost $10 million to $15 million just to put an exploration well in. That's a lot of money for a company to come up with when we don't have a lot of data available out there. So that's been a risk for quite a few companies. We see the developments going on in Alberta and Saskatchewan are where there's existing data from oil and gas. So that's very helpful. The brine chemistry may require pretreatment. There can be a lot of scaling issues. We see this a lot in the Salton Sea in California. It's a place where they have existing geothermal. They did their testing and they've got very high concentrations to the 600 sort of range of lithium. But their brine is very nasty, so the pretreatment requirements are quite high. It's quite a challenge. So we do see that. Every single brine is a little bit different and requires a bit more. We see on the pricing side, lithium prices have gone all over the place, much like all other commodities, but it has been kind of a roller coaster ride for many different startup companies looking at these projects for about the last 6 years. And then we see EV batteries are, you know, a lot of technology, or there's been talk of moving away from lithium. It is kind of unstable in EV batteries. We hear about fires, all of that. And so there is talk of that. But really when you look at the length of time it takes to move these technologies along, lithium is still going to have a good at least 20 years plus to really be part of the EV world. The other thing we see is pore space competition. So the diagram on the bottom and the right is an example of where you have a targeted saline aquifer, and in Alberta, say the Leduc is the example. And then we've got, and not so much geothermal in our case, but in some places it is, we've got lithium brine. Typically that reservoir would have already had oil and gas production, so it's depleted, or it might be producing oil and gas still up dip of where we're trying to produce the water from for the brine, lithium brine. But what we're finding in the CO2 sequestration, they want the same reservoir. So we've seen applications go in for various projects wanting access to exactly the same reservoir, but our regulations today don't really quite handle that very well. So this is something, again, where we have to catch up and look at how that's going to be handled for the pore space competition. So some of the takeaways is that the supply chain for lithium is complex. It is affected by geopolitics. There's a lot going on right now with China's production. Most of the production today, company can produce lithium chloride, but it gets sent to China to be processed into lithium carbonate or lithium hydroxide. So it's something that, you know, countries are trying to get this within their own. The lithium from deep brines is more environmentally friendly, has a smaller footprint, and utilizes those existing drilling technologies. And the DLE technologies are readily available. There's all different kind of companies out there nowadays that have their different sorbents and different types of technologies. There's membranes, different things. But you always must find the right match. So we find that most companies that are trying to get their project started will test at least 3 different types of technologies or sorbents even, and have to spend that time to test it out. They might have to start over again if those don't work. Each brine is very different. In Canada, we are well positioned. We have good resources available, and we have the knowledge and ability to work on these. And like with any critical mineral, the de-risking to commercial scale is a long road. We see for a lot of these projects, it's not an easy path to be on. The project exploration development costs are quite high. We're talking multi-billion-dollar projects for these projects. The stakeholder engagement early is very important. This is something that Vulcan has a very large community engagement. I mean, they're in the midst of population everywhere. Everywhere you go, you drive 5 minutes and you're in another town. It is very important for them. The project funding and the lender due diligence process is very long, and we see a lot of challenges in that. We work with a few companies on doing lender due diligence. It's something that GLJ does, and it can take years before we finally get that. But the transfer of skills and capabilities from the adjacent sectors, be it mining or from oil and gas, is really valuable to really kick off these critical mineral projects. And that's it. So I don't have questions.
There's questions already. How good is that?
Yes, hand up first.
Okay.
I was just going to ask, great presentation.